Hi everyone, welcome back. Today we are going to discuss about the transformer differential protection which are used in the power system protection and switchgear. So actually a differential protection which are used in the transformer or transmission line or generator or motor, whatever it may be. So generally the term differential, it means the current which is entering and the current which is leaving in a motor generator transformer. So the difference of these two current, the entering current and leaving current, the differential current, it operates the relay in order to protect the system, is nothing but a differential relay. So here, which is used to safeguard the transformer so that we can able to ensure the reliable operation to protect from the internal or external fault. And there are several mechanisms and several monitors which are used to detect, to determine, to find the current flowing in and out of the transformer. That is the current which is entering into the transformer and the current which is leaving into the transformer. If the both current are equal, the system is under normal condition. If there is a differential current is occurred, it denotes an abnormal condition and it isolates the faulty section so that we can able to avoid the damage to the valuable asset like transformer, transmission line, motor, generator, etc. So this is to minimize the risk failure and to maximize the transformers operations. So these are the different key component of differential protection. So one is the current transformer and the differential relay and the wiring and connection. So actually a CT is nothing but a current transformer which is installed on the primary and secondary of the transformer. It is both on CT or both on the primary of the transformer as well as secondary of the transformer. So the CT, it detect, it measures the current which is entering into the transformer and the current which is leaving into the transformer through with the help of current transformer and differential relay. So the differential protection, which is continuously comparing the current which is measured by the two CT. One is on the primary side, another is on the TC, secondary of transformer. If the both current are equal, the differential doesn't operate because the both input and output current are both are equal. If any abnormal is there, the differential will come and operate and it gives that tripping signal to isolate the transformer, in order to protect the transformer. And the next one is the wiring and connection. The proper wiring, it is nothing but pilot wire. Okay, so this the proper wiring and connection between the CT and differential relay. So with respect to the value of impedance, it is based on the distance from the primary to the differential relay, secondary to the differential relay. If both are equal, the impedance value will be equal. Otherwise, we have to insert some other adjustable resistance to match the resistance on both the head. Otherwise, it may lead to the some mismatch. And the operating principle of differential protection. So there are three categories. One is on the normal operation and the internal during the internal fault and during the external fault. So during the normal operation, the differential doesn't operate because the current measured by the CT and the primary and secondary both are equal, so the relay doesn't operate. So it will be as usual. And if any internal fault, when an internal fault is occurred within the transformer, such as winding short circuit fault, the current measured by the CT will no longer be equal. If both are equal and some other imbalance in the differential current, so here the tripping signal will be given to the circuit breaker to isolate the faulty section of the transformer and external fault. Here, if any fault is occurred outside the transformer, the relay will not trip. because the differential current will remain balanced and the relay will not trip. This ensures the transformer is not unnecessarily isolated for external system disturbance, improving the overall reliability of the power network. So it is only on the internal fault. And the differential protection, the advantages. So it is highly sensitive. If the entering current is 10 and the leaving current is 10.1, so there is a difference of 0.1. So a small amount of differential current, it operates the relay effectively. So the relay is very sensitive according to the differential current. And selective operation. So here this scheme is very selective and trip only the fault. Some of the relays, it cannot identify whether it's fault or due to some other, it is because of overloading or some other parameter. So it is selective. It is easy to detect that whether it's fault or some other else. Okay, during the external disturbance, and the reliability will be increased. The reliability of the system is increased, and so that we can improve the safety of the component like transformer, generator, motor, etc. And differential production challenges. So these are the some of our challenges, that is disadvantage. So it's because suppose if the CT is saturated, it makes some of the trouble, and due to the inrush current of the transformer and due to the tap changer influence and the commissioning and the maintenance. So these are the some of the few drawbacks or few challenges we are faced in the differential production. And these are the advanced differential protection schemes. So that is resistance, harmonic resistance, percentage differential protection, bias differential protection. These are the some of the variations which are used here. And the modern trend in differential protection, that is microprocessor based relay and conditioning monitoring and IC based integrations are used in the modern trend. And ensuring the reliable transformer protection, it is based on the proper design and installation and regular testing and maintenance and continuous monitoring. So if the design, installation, testing, maintenance and continuously if you are monitoring, so we can able to ensure the reliable protections. Okay, so this is an assessment. Any transformer need to be protected from transformer fault or fault occurring on the transformer connected system, fault within and on system and other fault. So put your answer in the comment section, and these are the few text and reference books for this topic. Thank you.